right, here we have f of x equals negative x squared minus 4x minus 4. And we want to find the equation factored form. So to find in factored form, we have negative x squared minus 4x minus 4. First thing we want to do is we want to pull out that negative 1 to rewrite as x squared plus 4x plus 4. So what multiplies with 4 adds to 4? We know that will be x plus 2 times x plus 2. So our equation in factored form is negative 1 times x plus 2 times x plus 2. All right, so to find the x-intercepts, we need to take our factored form and set them equal to 0. So in this case, there's only one that's set equal to 0 because they're the same thing. Subtract 2, and we get one x-intercept at x equals negative 2, or you could say negative 2 comma 0. So let's plot that point. Only one of them. All right. Well, our y-intercept is when x is 0. So let's think about this. Negative 0 squared is 0. So again here, this is when x is 0. The one above this is when y is 0. So we have 0 minus, 4 times 0 is 0, minus 4, which means we have a y-intercept at the point 0, negative 4. Okay, point symmetric to the y-intercept. Okay, in order to find out a point symmetric to the y-intercept, we first must go down and we must find the axis of symmetry. So a method to find the axis of symmetry, which I don't think I mentioned in the other videos, is you take your two x-intercepts, you add them and divide by 2. So in this situation, our two x-intercepts are at negative 2. So we're going to do negative 2. Move this over a little. Plus negative 2 divided by 2, which equals negative 4 over 2, which means our axis of symmetry is at x equals negative 2. So we can draw a dotted line, which isn't really part of the graph, but it shows us our axis of symmetry so that we can find a point symmetric to the y-intercept. Let's think about this. This is 2 units over, so this would be 2 units over. Meaning we would have a point symmetric to the y-intercept at the point negative 4, comma, negative 4. All right, leading coefficient here, there's a negative value. So our leading coefficient would be A. Let me make sure this writes again because it won't. A is equal to negative 1. All right, does the parabola opens which way? Well, let's graph this now. We didn't finish graphing this. We can see that this becomes our graph once we find our axis of symmetry and our vertex. So it opens down. Okay, the vertex therefore represents a max. It is the top of the hill. And our vertex is at the point negative 2, 0. Okay, increasing and decreasing intervals. Well, it is going to be increasing this way. So it's increasing from negative infinity to negative 2, which means it's decreasing from negative 2 to infinity. All right, and the last thing, the average rate of change from negative 2 to negative 1. Well, let's see, negative 2, we're at 0, so we're going down 2 over 1. So this would be negative 2 over 1. From negative 1 to 0, from negative 1 to 0, we're going to be going down 2 again over 1. So negative 2 over 1 again. And then let's see, from 0 to 1. Well, what is our answer for 1? Let's either be negative, or 1 squared is 1, so negative 1 minus 4 times 1. So negative 1 minus 4 is negative 5. Negative 5 minus 4 is negative 9. So which I guess would be right here. So let's see, we would go down 1, 2, 3, 4, 5 over 1. So this would be negative 5 over 1.